Welcome back. Part 3 of your how to solder. Okay, we're going to get down to some nitty-gritty today of doing some proper soldering onto some circuit boards, PCBs. Okay, it's a single-sided one that solders some through hole onto. Strip board. Okay, I bloody hate this stuff, but we'll cover it anyway. Okay, we'll do solder buckets. Okay, you've got connectors like these. Okay, D-subs, whatever. Generally, if you've got a cable, you want to connectorize it. Okay, usually you get solder buckets which look like these, so we'll do those. What else will we do? We'll also do the so I say the good, bad and the ugly in soldering joints. Okay, so I'll show you what to look for a good joint, the bad joints that can happen, okay, and the not so pretty ones, but they'll do the job. And soldering joints are really, really important. Okay, so start off with this. Okay, connectorising that, go from wires to connectorising wires. Okay, that will sum up that section of all the wires, and we'll do some stripboard work. Okay, lots of keen on this stuff because it doesn't solder well. You don't get great solder joints on it, and we'll do that. But it's the intermediate between a PCB and a proto board. So yeah, and we'll finish up doing this, and then part 4 we'll look at some SMDs. Got some SMD on here, and we'll show you about soldering those. Okay, so first up, solder buckets. Just grab some wire. Some wire here. Just use that bucket, whatever. Okay, and here we go. Don't forget, first things first. Strip your wire, twist it, tin it. If it's solid, just strip it and tin it. Okay, it still needs tinning, but all the stuff goes on with this. Okay, but before we even start plugging in wires and applying solder, okay, for a solder bucket, there's a few different ways how you can solder it, and the most common form is to use a twisted solder. So prep your solder. We'll prep a bucket first. Soldering. Prep your solder. Tear off some. And what you want to do is to let's just solder. Fold it in half. Okay, so it's folded in half. You can see it there. Okay. Let's do it against that computer. There you go. You can see it there. Okay, and what you do is you twist it, just like when you twist your threaded wire together. You keep twisting it and twisting it and twisting it until you get a length cable that's nice and tightly twisted together. And that looks something like yeah. Okay, so you've got all the twists here. Grab your wire cutters, trim off the loop at the top. Okay, so you've just got twists, and you want to take your pot, just measure it, sit the twist into the bucket, like that. Okay, and just trim off the top so it's just proud of the bucket. Okay, so all that you have is a piece of twisted solder sitting in your bucket. You can see that it's not too clear. See it on the picture up here. Okay, as usual, they're all up now. Okay, close up images, you can't do this. Okay, so first of all, prep your bucket. Twist the solder, shove in your bucket, snip it off to the right length, and there we go. The reason why you do this is because you have a bucket to hold, you have a wire to hold, you would have some solder if you're going to solder it by hand to hold, and you got your iron to hold. It's a hell of a lot of things to hold, and we've only got 2 of these. And even if we use our helping hands, that gives us 4 of these. But the only trouble is, you use this to hold your socket in place, stop it moving about. So let's use up that. But you still need to hold the wire, you still need to hold the soldering iron. What do we do to hold the solder? We can't, so you do the solder twist and you put it in the bucket first. Okay? Good tip. Okay? Load up your bucket first. Some people, what you can do, and what some people do, is they actually, instead of doing the solder twist, okay, and pop it into the bucket, they'll actually do they'll fill the bucket with solder. So they'll apply the iron to the bucket, and then feed in the solder, and you feed in the solder into the bucket. So it's a bit like tin the bucket. The only trouble with doing that is you have to apply flux afterwards. Okay, you have to flux it afterwards, because when you apply the solder to the bucket, you take out all the flux out, and if you're plugging in a wire afterwards, you need to reflow the solder in the bucket. You need to plug it in. If your cable's been knocking about for a while, then it may be particularly nasty, and the solder doesn't take too well to it when you do tin it, and the solder's all here, there's no flux, it doesn't flow that well between 2. Can do it that way, okay. I'd say 7 times out of 10 normally it's okay, but the more buckets that you have to solder on a connector, more higher chances are that you start to run into problems. Okay, so it's always best to do the twist, because you've got the flux in there, hasn't been activated or anything like that, it's sitting in there ready to use, you've got solder sitting in there that's ready to use, and hey presto, all that you've got to do is one touch of the iron on, plug the wire, and take the iron off. If you do it, the other reason why I prefer doing it this way is because what your pins are all held in the socket with is a piece of plastic, okay, and this plastic isn't heat resistant or anything, it does melt, and the more time that you spend with your iron on this pin or going back to the pins, there's more chance of you actually damaging this plastic socket. If you damage the housing, this the bucket can come loose, which is connected to the pin on either side. It can come out of alignment, and it leaves it with a bit of a nasty job, and you end up with all bloody bits of melted plastic everywhere. And it's, twisted solder method you can't go wrong with. Like I say, you can preload it. You just have to be very, very careful when you do that. So let's get down on the bench, and I'll run you through step by step. Right, so then, here we are, down on the bench. What do we do first? Put our iron on, and while that's heating up, let's prep our cable. Okay, and trim the ends off. There's the wire strips I ain't got on wire. Do it dirty and just strip it with it. Wire cutters, who cares? Yeah. Once you get used to using them, you can take shortcuts. I don't recommend it, but yeah, well, whatever. Okay, so twisted up our wire, get our holder, do flip, helping hands, grab our soldering iron. Don't forget, check your tip, always clean it. Okay, this case is pretty nasty, so today I'm going to use a tip tinner. Okay, it's been heavily used recently. You just want to stroke it across the top. Okay, this one has got bloody holes in, because I've seen people actually stabbing the iron into this. It's the wrong way how to use it. Just stroke the iron across the top. Okay, and it builds up a layer of tinning on your iron. Clean it off, and there we have it. A nice clean tip, extremely shiny, all tinned, ready to use. Okay, this stuff, like I said, it's called tip tinner. It contains a mixture of solder dust. Okay, it's solder in a dust form, okay, granulated, and it's mixed with a flux. Okay, but the flux in this is very, very corrosive, and it's designed to really strip back the oxidized layer on your soldering iron, to bring it back and apply solder to re-tin the tip. Okay, it's a good way of refreshing your tin, is to brighten your tin. Okay, really good stuff. If you do a lot of soldering, I recommend that you get a hold of that. And if you don't do a lot of soldering and your soldering iron does hang around for a long time, your tip is going to get all knackered, dusty, dirty, crappy, and it's a good way to tidy up your iron. Okay, so iron's all clean, it's up to temperature, wire's all twisted and stripped, so let's tin it up. There we go. Right before, just under, that's done, that one, all done. As usual, don't have to put a great amount on, all tinned. What you want to do is to, first of all, without anything in the holes, just place your wire in the hole, okay, and gauge how much bare wire you need. So in this case we don't need a huge amount. Trim it back, okay, so you need a few millimeters, just so that it sits in the hole nice and neat. You've got a little bit of overhang, and it all goes in there. Okay, so what do we do next? Take your thingy. Now, as you notice, my helping hands are clips are down on the bench. They're not up in the air. Why? Because this is going to be held down. Pop buckets upright, and I don't want it to move about a great deal. Okay, and I'll be applying the soldering iron to the top, so I don't really want it moving about. So use both of these. Make sure it's down. It's not going to move about a great deal. Okay, and we grab our solder wire. Okay, you twist it up and everything, so loop it over, twist it, trim whatever you need off, and whack it into the solder bucket. Got a little bit too much there, so I just trim that back. Okay, you only need about 5mm or so twisted in there. Okay, tip for you: if you do have thicker solder, okay, you don't actually have to twist it. The twist is only there in order to make up the thin wire into a thicker wire, so there's actually enough in the hole. It should fit snugly in the hole. Okay, so that's solder in, and like I said, all you have to do is to place the iron on the solder bucket. It will melt the solder in, and then you can slide this in without taking your soldering iron on. Solder to solder, you do it reasonably quickly. The flux is all there, done, job done. Take your iron off and it'll be soldered. Okay, there's no need to reapply the iron, so toss it on, whack it in, take it off, and there we have it, soldered in. Yeah, you can see that there, that's one, all nice in there. It's a little bit blurred so you can see it on the picture. I did one earlier, and for an example, and there we have it. It's in there, it's all done, it's horizontal, there's hardly any movement in it, brilliant. What you can do, okay, just like before with a wire, you can use a little bit of heat shrink. Okay, so I've got the heat shrink over here. I'll do that somewhere. We'll do another one, and what you can do is you can just trim off a small amount if you want. Okay, it's always useful to put on heat shrink on when you're doing one of these, because it does protect your joint as well. So just like before, trim off the solder that you need, whack it in the hole. My heat shrink is on the cable this time. You can do this for every single one, for every other one. It's entirely up to you. It depends how fiddly the cabling is. If it's quite a rigid cable, then you're not going to get much movement in it, so you don't need any strain relief or anything like that. You do it short, okay, you're not going to worry about short circuits or anything like that from wires touching. But if you use threaded, I do recommend you use the heat shrink because it acts as a boot around the solder joint. So instead of the actual joint moving about at the solder joint, you could break. Okay, it'll actually move. You shift the forces further up the wire, and it'll flex around further back, around where the cable is solid, and you don't get any breakages or anything. Okay, so it's all on there. Usual, whack the iron on, whack your wire in, done, soldered. You slide that down and you can touch it up. Okay, so there we have it. You can see that there, it's got the heat shrink around it, it's all protected, and you can do it that way if you want. That's how you do buckets. Okay, these particular buckets that you get nowadays, they're still called solder buckets, but they're really half buckets or partial buckets. Okay, because when buckets first came out, they were the bucket shape in it, but like that, and you put your cable in there. Okay. The problem with that was you was applying solder to the top. You didn't know whether or not it was actually filling the bucket. Okay, so you got no idea of how much solder has actually flown into the bucket. I mean, for all you know, it could have just soldered across the top, and you got a huge air bubble down here. And it looks like that you get a really good joint, when in actual fact you haven't. So what manufacturers have done now is that they've scrapped that design and they've gone for a half bucket, so it looks something like that shape. So you got the bucket here, okay, and you end up with a, so I'll show you if I try and do this. I'm terrible at bloody drawing, but it'll look something like that sort of shape. Oh, give up. It looks like that. Oh, whatever, you know. Half a bucket. It's got a chunk chopped out of the bucket, okay? And you do it that way so you can actually see how well you solder. And ideally, you're looking for a fillet shape joined to that. So that's your solder buckets. They're a really, really easy thing. So you get them on all connectors, D subs of all sizes. You get them on all other connectors. The only time when you get the full bucket is if you've got any coaxial connectors, solderable coax connectors. Normally that's only semi-rigid. Okay. And the centre pin is a full solder bucket. Okay, and what the manufacturers have done in order to tell whether you've got a really good solder joint is the actual bucket. Okay, you've got the pin coming out down the bottom. Okay, so this is your pin going into whatever your bucket's here. What the manufacturer's done is whacked a little hole in the bottom that acts as an air hole. So when you flow your solder in, the air comes out of the hole. It all fills your bucket. You don't get any air holes or anything like that. And also, you can tell whether or not it's soldered fully inside, because you'll see solder leaking out of this little bucket on the side. Okay, and yeah, that's the only time when you got a full bucket is in say like coax or a really, really old D sub. If you search through these on there, you have to probably go back about what probably about 40 years now to find one of those full buckets. They're really rare to get hold of now. And, I haven't seen one for donkey's years. Okay, last time I came across one was when I was going through an old box of used components in my shed, and yeah, I had some, used it, still good, but yeah, you just have to be careful with them. But the partial or the half bucket is the one to go for. And moving along, stripboard. Okay. No, actually, good, bad, or the ugly old stripboard. It's difficult. It's chicken and the egg. Do I show you what a good joint is, or do I solder and then show you what a good joint is, or do I say you know what to look for, you know what? Sod it. Let's do this. Okay. Soldering time. Resistor, stripboard. Solder it. Okay. First of all, Whenever you're doing any soldering on circuit boards, okay, make sure that you start off with the lowest profile components. Okay, don't go for, say, the highest profile components. Things like we've got this little one made up here. You've got on here we've got chip holder, you've got resistor, you've got a edge connector, you've got a screw terminal there. It's all soldered on. Okay, the reason why you go for the lowest profile first is because if you turn it upside down, okay, you have to imagine that you're soldering it. If you solder on a large one first, place it on the desk over here so you can see it. Okay, these connectors are quite proud of the board, so your board isn't laying flat to a flat surface. That means if you've got any small components, okay, when you pushing through the holes, you turn the board over onto the bench. These are going to drop at an angle, okay, and even though I pushed it through earlier, you can actually see on there it's all bent up and all nasty, and it's sitting proud of the board, and yeah, it doesn't give you a particularly good finish. So you start with the flattest first. That way, when your board is upside down on the desk, everything of that particular size is soldered first. So and you build up the height as you go. So you might do, say, diodes first, then you might go on to resistors, then you might go on to chip holders. Okay, I recommend that you use chip holders. Don't solder on a chip directly onto your breadboard. Okay, ICs, things like that, they're very sensitive devices. Okay, you don't want to overheat them, otherwise you will destroy them. Okay, first time round, you're going to take a while soldering each pin, so it's always best to go with a chip holder. Okay, you can always plug in your chips afterwards. Okay, any sensitive microcontrollers or anything like that, save damaging them, use these. Okay, so you build it up as you go along, nothing drops out. And if you take a look at these, once these go through the board, you haven't really got any pins as such to bend about on this side. Okay, once it goes through, so you can't bend a pin out to hold the component in place while you're soldering it. So all that you deal with is the friction holding it into the socket, and if it's on a strip board, it's bugger all, there's none. So these holes are huge, and that's one of the problems with strip board, is huge holes. So what we'll do first, we'll bend our component legs. Okay, you can use your pliers to bend your components to shape, or around your finger if you like. Work it through your board. Copper to the bottom. Okay, because you want to solder copper, it's pointless it being on top unless it's double-sided, and even though it's double-sided, it's very rare that you solder on the top side. Okay, so that's through the board to your legs, and what you do first is you bend one of the legs over 90 degrees, and that keeps your component in the board. Okay, flat on the opposite surface, one leg standing proud at 90 degrees, the other one 90 degrees flat to it, and that's your component ready to solder. Take your soldering iron, grab your solder, and what you do is you hold the soldering iron between the component leg and the copper. Okay, make sure that the iron tip is on the copper and the leg. You have to apply the same heat to both. If you don't, you end up with either solder not taking to the copper and it all takes to the leg and you get a solder ball, or it all takes to the copper, it doesn't go to the leg, and you end up piling more and more solder on it and nothing gets soldered anywhere. Okay, so it goes to both, and push the component to the edge of the hole. Okay, very important, that to the edge of the hole, so the solder takes in the joint. So as that's on your board, you feed your good tip. Okay, if when you apply your iron to the board and you're feeding the solder in, it doesn't flow, okay, because you want this solder to apply to the opposite side, to the component leg and copper, and this is on the opposite side, just like this image up here. If it doesn't flow, what you can do is to change the heat profile of your iron by adding a little bit of solder to the end of your iron, and this will bond between the component and the copper on the opposite side, and then you can feed in just enough just enough solder so it solders on all sides. Okay, so there we have it. It's all the way around, it's soldered in place. Once that side's soldered in place, you can trim it off. Solder in your next wire, same principle, a little bit on the side. Just feed the solder in, you don't need a lot. Okay. And there we have it, that one's soldered in. Now you have to be careful with strip board, because the holes are quite large, okay, you end up with this on this side. If you can see this too well, maybe not too well, but it's not soldered fully around. Because the component leg moves about in the hole quite a lot, okay, you end up with a really piss poor joint, which is why I absolutely hate soldering. So you have to inspect your work and then go back and touch up. Okay, snip your wire off. Okay, and there we have it. As component is soldered on, it's flat to the board because we've bent the pins. Always solder with your pin hanging up. And whatever you do, don't get carried away with plugging every single component imaginable of that particular size through your board first, because what will happen is all these legs are sticking up and they'll get in the way of you getting the soldering iron in and around the circuit and your soldering, and they just get in the way. Just do it one or two at a time. Okay, don't get carried away with populating your entire board, so it becomes a nightmare to solder and you end up doing a really rubbish job, similar to we've got one over here. Okay, someone did that with this board, and yeah, all the components are soldered, but around this area it's turned really manky, where they've had to do multiple touch-up work, and over here as well you've got solder blobs. None of them are really, half of them aren't concave shape, they're not filleted, they're domes, where he's had to load it up with multiple touch-up jobs and what have you, and you end up getting a really piss poor job. So take your time, don't rush it, okay? And also don't leave the iron on the board for a super long time. The longer you leave the iron on the board, the hotter your component gets, and you can damage your components. They can only take so much heat, just like they can only take so much current and voltage. Heat's one of the properties as well, how much heat dissipation they can take. So there we go, that's on a strip board, and like I said, these things are headers, you can whack these on. Okay, each pin is in its own row and you can cut in between if you want, but you know, we'll do that at a later stage when we start working on something. And what you do on these ones is exactly the same as before. There's no legs to actually chop off. You put your iron on, you feed your solder in, and job done. And you just go down the row, do it for each one. Okay, you don't need a huge amount of solder. On strip board you might have to, because you have got a large hole surrounding your pin, so you might have to load it up with that little bit more solder. You don't get a true fillet joint always on strip board, because that hole is quite huge. Okay, you can end up with a fillet with a bump in the middle, and it can be a little bit awkward. Okay, there we go. It only took a couple of seconds. That's that chip socket soldered in. Okay, and what you're looking for is a nice shiny joint. It's got a nice fillet or concave shape to it. You don't want too much solder in that, otherwise you won't be able to strip away the tracks in between, and you don't want the solder spreading out across the entire track, so you just use the bare minimum. Okay, just to get that joint, and there we have it, that's that. Exactly the same for PCBs as well. Okay, and what I'll do before I do this, okay, we'll just run through some of the the types of solder joints that you can get. Right then, solder joints, okay, good, the bad, the ugly, okay. The ugly ones you can get away with, good ones are brilliant, bad ones, well, you have to redo, okay. And I'm going to run through what a good one is, what a bad one is, how you get a good joint, okay, the reasons why you get a bad joint, okay, and some possible reasons, okay. And yeah, the ugly ones in between, ones that do the job fine, okay. So, whiteboard time. Yeah, a little bit messy, but still need to get a new one, better one. Maybe get a tablet at some point. Yeah. Right, so what we're looking for when we for a good solder joint. First up, it has to be nice and shiny. Not always the case for unleaded. You can get dull joints, but if you get the ones with the bit of nickel in the unleaded, it is a shiny joint. So, you know, looking for shiny joints, good sign. Indicates a good wetting and everything, and it has to be a filleted joint. Okay, and by that I mean this. Okay, if this is your component leg, okay, or whatever your component is, that's the top. Through the board it goes off to whatever component, okay, and this is your PCB down here, or your strip board, okay, component leg for the strip board, you got your pad here, or your track on the other side, okay, your bit of copper, okay. What you're looking for, first of all, is a nice filleted joint, okay, and it looks like that shape, okay, so it's a nice fillet to the joint. You should see it wetting, so it should pull, the bottom of the fillet should go pull down towards the copper, and the top of the fillet should be pulled in up towards the leg of your component, okay, the sign of good wetting, okay, must be shiny, okay, and that is a really good joint. That's what you're aiming for, okay. And well, that's it. That's all you really aim for. And the way how you get that joint is, like I said when I was soldering, you need to hold the iron, tip of your iron, in the joint. If that's your iron there, okay, that's your tip. Okay, you want to hold it on one side of your component, on the copper, okay, that you're going to be soldering to, and on your component leg, okay, and you feed in the solder, so this is your solder, into the opposite side, okay. Your iron applies heat to the copper, heat to your pin, okay. Copper is going to be surrounding the pin just like a pad. It's what we call a pad on a PCB, okay. We do a picture of a PCB here. You've got your track, you've got your pad with a hole in the middle, okay. Component goes through the hole, you solder around the outside edge. If it's on strip board, okay, you've got your strips running down, something like that, holes in your strips. What you're looking for is it to be completely covered around, just around the hole, okay, so it's around that area. You don't want to spread up and down. Sounds like there's a fire alarm somewhere, not in this building I hope. Nah, it's next door. You'd know about it if it's here, because the bloody siren's right outside the door. Oh well, yeah, so if you don't want your solders to flow up and down these tracks, you just want it around a component, okay? Now you don't want too much solder on, you just want the bare minimum just to create this filleted joint, okay, and it has to surround your component as well, okay, and we'll go through some images. Which side? Let's do it up this side, okay, up here. So, first up, what do we have? Well, we did solder buckets, so here's an image of a decent solder bucket. Okay, as you can see, the solder's flown into the bucket. It's not overflowed, it's not bulbous or anything. Okay, whatever you do, don't go for a bulbous solder joint. Okay, especially on the bucket. Okay, if we've got a bucket, okay, it looks something like that sort of shape. Okay, with our wire going in this way. Okay, so we've got our threaded wire here going into our hole. We've got the insulation coming down. No, not the insulation coming down. Threaded wire going into our hole here. Okay, what you're looking for is a nice filleted joint here. Okay, it's just on this section here. We've got our cable going in. Okay, and what you should see, okay, is partially this wire just sitting on top, just partially. Okay, it should be tinned. Okay, it should be soldered, all the threads will soldered together, but you should still be able to make out some of the threads. Okay, if it's bulbous and it goes the opposite way, okay, you don't know whether this solder has been pulled back into the actual bucket itself. It could be just sitting over the top. Okay, and this cable, because there's a lot of mechanical connections in your mechanical movement, okay, in your connectors, okay, you're always going to flex about, your pin's going to move about. Okay, if this hasn't soldered in properly, okay, you've got a bump here or it's bulbous. Okay, you don't know whether it's soldered in properly, and with a little bit of tugging, a little bit of movement, this wire's going to work loose. Okay, so try and remain to the fillet. Okay, on the solder buckets, and it should be shiny, just like this one here. Next one is your wires. Again, sometimes it can come out a little bit bulbous. Try and aim for the fillet. When you're attaching wires together, you might want to add that little bit of solder. So solder it first, make sure that it takes, it's solid. You might want to add a little bit more on, depending on where it is. If you get a lot of movement in the cable, it's not cable tied down or anything like that, you might want to add that little bit more. So you may not get that filleted look, but not too much again, because you don't know if you're getting the air bubbles in the solder that get trapped in between the cable strands, things like that. You know, it can cause problems. Next up, okay, so that's your buckets and wires done and what have you. Next up is the strip board. Okay, that's a really good joint on a strip board. It's nice and shiny. It's not flown to the other holes. Okay, so you can still fit your components through the other holes. Okay, you're not going to obscure the holes. You're not going to stop any components going through. On the strip board, the fillet might be slightly bulbous, so we'll go from a fillet first, and it'll bulge slightly, but then it'll go back to a fillet up to the wire. The reason for that is because the holes on your strip board are quite large. Okay, so you've got an area where the copper isn't near the component leg, so it doesn't always fillet very nicely. Okay, so sometimes you can end up with a little bulge. Okay, same thing goes for on a PCB. Okay, which we're doing next. If the hole is particularly large, you may end up with a bit of a bulbous fillet in the middle. So it goes into a fillet and goes into a bump and it goes back to a fillet. But if they're the right size for if the component legs are the right size and the holes are the right size for the component legs are the size for the hole, you should end up with a nice fillet. It should be nice and shiny. Also, make sure that it goes around the component leg, not like this one. Okay, this has only been half soldered. Okay, the solder's only took to half the leg. Reason for that is either the copper hasn't been cleaned off sufficiently, so it's got some oxidisation on the copper. Okay, so the solder hasn't flown to the opposite side that well. Hasn't took to the copper, hence hasn't took to the leg. It's left it half unsoldered. Another reason, the temperature of the iron isn't hot enough. Okay, so it's only hot enough, suitable hot enough to get half the component hot. That's around by the soldering iron. Okay, so it's not flowing to the opposite side, it's not melting properly. Okay, not flowing into the joint sufficiently enough. Also, another reason why it might look like this is because your soldering iron's too hot. Okay, and as all the solder is being sucked away, okay, and it's all pooling up on one side of your component. Okay, so make sure that you get it all the way around your component. If you can't get it to flow on both sides, move your soldering iron to the opposite side, okay, and just touch up the work. So you're feeding on one side, solder one side, and you're feeding the other side, solder the other side. Sometimes you have to do that on very large pin devices, okay, very large devices, you have to do that. So that's that one. The other joint, like I said, the bulbous joints, like this one on the strip board, okay, avoid this like the plague, okay. This is way too much solder on your board. If they're bulbous, it can overhang the tracks on your strip board, and it can cause short circuit with the pin next to it. Okay, well, if you've got a bulbous joint on both sides, they can short together. Okay, crap joint. Okay, also you don't know whether the wetting process is took properly on the copper, okay, or to the leg, because it's completely covered. Okay, it's just like having a lump of solder on the end of your wire. Okay, you don't know what's going on underneath if you've got a really good connection. What you can find is that it's only being held in place by the flux residue, and over the course of time it will work loose. Okay, you only have to knock the board, bash the board, a little bit of shock, a little bit of vibration, and you've got an open circuit. So be very careful. Okay, not too much solder, not too little solder, just enough just to create that fillet. Just like before, it's shiny, yeah, that's one thing, that's good, but it's the wrong shape. It's a bad joint. Next one along, okay, we're looking at good and bad, and this is on a PCB. Okay, you can see a good filleted joint. Okay, it's very small, very shallow. Okay, this is on a tinned copper board. Okay, it's one that tinned, and it's quite a shallow joint. That's because it's a through-hole plated. Okay, so solder's took to the joint, it's gone into the hole, okay, and it's actually sitting in a round component. It's nice and filleted. As you can see, it's slightly dulled as well. It's because it's the unleaded solder. Okay, but the pin next to it, okay, it's very bulbous. Okay, what's happened to this one is because the pin goes through the ground plane of your PCB, you've got a huge amount of copper surrounding this pin. What's happened is all the heat has gone into the pin of the component, but it's been drawn away by this large area of copper around the component. So your copper surface isn't hot enough for the solder to take, and all the solder has piled up on the component leg. The way around that, okay, and the reason why it's happened is because one, the soldering iron is too cool. Okay, so as fast as it's heating the copper, the heat's been took away. What you need to do is turn the temperature of your soldering iron up, and that's a good reason for having a temperature controlled soldering iron. Okay, and it avoids this problem of solder building up on your pin. If it's not a tin board, it might be copper. It could be because you've got oxidized copper around the board and you haven't got sufficient enough flux on the board in order to clean off the oxidization. You haven't scrubbed the board or anything like that. You haven't prepped the board enough. And again, all the solder isn't taken to the copper because it can't flow because the oxide laying is all building up on the component leg. Okay. If it's a particularly big bulbous joint, just like before on the strip board, okay, you may get partial wetting, you may not, but usually it will work loose. Okay, so you have to make sure that you retouch up joints like this. And again, next picture, this is a really good one. Okay, this is a tooling iron package that's soldered onto the same board as the previous one. Okay, as you can see, all the pins are all concave, they're all filleted. Okay, they're all surrounded, all soldered on there nice and neatly. You can see the wetting process, it's nice, it's all the same colour, yeah, it's a really good joint. Another one that's a really good joint, I did with the unleaded just to show the difference. Okay, this is on a edge connector. Okay, it's actually on a header. As you can see, it's a square header, so the fillet is slightly squared. Okay, so it goes off in that direction and it goes off in that direction. It looks a little bit like a pyramid. Okay, nice and shiny, nice and filleted, good joint. Unlike this header, next, okay, this is a dry joint. Okay, this is where the solder hasn't flown into the liquid state. It's actually remained in the plastic state. Okay, and what's happened is it's soldered all around the component. It's tried to wet. It's not all solder hasn't completely melted, and when it's re-hardened, it's gone back to a solid. Okay, it's gone back to a very irregular structure the solder has, and it's gone very brittle, and you can actually see got some cracks, divots, and whatever. You can see it's not a very nice fillet to it at all. Okay, and that's in actual fact a dry joint. And what will happen with that is dry joints may not cause you a problem straight away, but because they're dry and they haven't wetted, okay, it will crack from the board, okay, especially if it's a header. Headers are going to be taking things like plugs to it. Okay, if it's a, say, I don't know, a four-way header, it's got a four-way plug sitting on top, some cables going to it, you can have some movement, it's going to crack this like no tomorrow. Okay, it will be wasted. So again, this is because the soldering iron either hasn't heated up enough, okay, to melt solder properly, or it hasn't heated the joint and the copper sufficiently enough before you started applying the solder, and you took the heat away before it's actually gone into liquid state. Again, that's another one that you've got to avoid. So that's the good, bad, and the ugly joints. The ugly joints are ones in between. Okay, it might go from you know, the fillet to the bulbous to the fillet. It's not a proper fillet, but it's nice and shiny. You can see the fillet there. It's all took. It's a bit of an ugly joint, but it does the job. It's fine. May not look great, but it's okay, passable. But what you're really looking for is the filleted joint. If your joint is dull, scrap it. Okay, unless it's unleaded, then you have to make a judgment. If it's not a fillet, scrap it, redo it. If you do end up putting too much solder into your joint, or you have to touch up your joint, if it was bulbous on your leg and you have to put the iron into it again and flow a little bit more solder in, so take to the copper, okay, and you end up with a bulbous joint, okay, use some of your solder braid just to take off the excess solder. Okay, so solder braid on top, take the excess solder off, and I'll cover doing that when we do our desoldering exercises at the end of all these parts, and we'll also do some touch-up work, some rework, hardwire connections, broken joints at the end in probably part 5 or something like that. So that's your good, bad, and your ugly. Next bit, what we're going through in this little part is doing it on PCBs. Okay, slightly different to stripboard. Stripboard, you've got long strips. PCB, round pads, square pads, oval pads, and what have it. And it's yeah. So you have to solder up something like this. Okay. Right, back to the bench. Okay, and PCB time. Got one circuit board here, okay, that I made up. Okay, it's a prototype for a little bit of work that I've been doing on the side, but made nudges up of it, so put the wrong footprint on. It doesn't fit my chip, so I'm going to use this as a test board, and I'm going to solder a component onto it. Okay, just to show you how to solder onto a PCB. It's not much different from stripboard. The difference is the tracks are a lot thinner. Each component has its own dedicated pad and placement, and yeah, that's it. So whack your component in through the holes. Yep, it's that way around. Bend it into place. In the case of this one, it's going to be flat to my board, like that. Okay. Turn it upside down. Bend one pin back, just like on stripboard. The other pin upright, and get into my helping hands, just to keep it stable while I solder it. Done. Iron on. Get my solder ready. Okay, and we're ready to roll. and hopefully the joints will come out looking something like on here. Nice shape. There's no need to put any flux on the board or anything like that. But one thing I didn't mention on the last one here, okay, if you do have trouble getting the soldering iron tip into the joint between your copper pad or track or whatever on your component leg, what is a good idea is to load up the tip with some solder first. Okay, up to temperature, almost up to temperature, so it's just going. Let's put a blob of solder onto your solder tip like that. Okay, what this does is it creates a sort of like liquidy sort of coating to it that adheres to the soldering iron, and this will actually mould to the shape of your joint, and it will improve the heat transfer to your device. So rather than just having the very tip of your iron, it's actually a blob of solder on there. It will merge into, so if it's a triangular joint or an angle joint or anything like that, your blob of solder will just get in there, because the flux has all been burnt out. It won't actually adhere to your component leg, but it will mould to the shape a lot nicer, and the heat will transfer to your component a lot quicker. So just like on your board, place your component, your soldering iron between the copper and the leg, feed in your solder, and job done. Trim that one off, stand up the other one, bend it into shape, iron on, and feed in the solder, and there we go, it's done. As quick as that. Like I say, trim off the legs and look for the concave shape, and it's all soldered on. Simple. Okay, on there it's all in shape. I've got one leg trimmed off there so you can see it, and if you can see the filleted shape to that, nice and shiny, soldered all around, and job's a good one. Let's trim off the other one. Right, soldering done. And I'll take a picture of that and I'll flash it up here right now. So that's you soldering onto PCBs. One thing that just want to mention, once you've trimmed off all your wires, okay, what you might want to do is grab we're back again. What you might want to do is grab hold some IPA and a ESD brush. Okay. Reason for that: on this board, okay, you got some flux residue, and sometimes not all the flux gets burnt off, and you end up with some crap all around your joints. Okay. If the flux is still active, okay, that can eat away at your copper slightly over the course of time and cause problems. It shouldn't do, okay, but just to neaten things up, you can spray it over, spray some IPA on, and then just give your board a bit of a scrub over like that, and end up with a really clean and even more shiny joint. Okay, it gets rid of all the solder residue and flux residue and all the other junk that might have been on your board. You may have had a bit of grease from your fingers on your PCB as you're soldering it. It builds up and you get a black mess. And it just cleans it off, and it makes a nicer finish to your board. So that's it. PCBs are very easy compared to stripboard. Just dot it on, done, clean it up, sorted. Next, we'll do some, on the next video, we'll do some surface mount work on here. I'll use the same board. Okay, I've got a surface mount chip that can be mounted on just there. I'll give you a demo on that one, possibly knock up another PCB and give you a demo on another one, because there's various ways here you can solder surface mount components. Okay, and we'll cover that. So, till next time.